Okay, I'm gonna finish up chapter 4 recitation worksheet. So the next one was number 6. Okay, so it says calculate the molarity of a solution that contains 0.175 moles of zinc chloride in exactly 150 mils of solution. So for molarity, we just need moles divided by liters. So they give us volume, 150 mils, but we need that in liters. So we just have to divide that by 1,000 to get to liters. Okay, so it's 0.150 liters. So that will give us a concentration of 1.17 molar for our answer. Okay, and then 6b, it's asking for how many moles of nitric acid are present in 35 mils of a 4.5 molar solution. So they're giving us molarity and volume. So all we have to do is take molarity times volume. So just rearranging that equation, putting the liters up here to find moles. Okay, so we're going to take 4.5 molar times the volume. So it's 35 mils, but I've got to change that to liters. So just divide by 1,000 and we get 0.035 liters. Okay, and that gives us 0.158 moles. Okay. And then last one for number 6. How many mils of 6 molar sodium hydroxide solution are needed to provide 0.325 moles of sodium hydroxide? So we're solving for volume now. So here, if we take moles divided by molarity, then I'll have liters. So I'm just rearranging this equation, moving liters up here and then dividing by molarity. Okay, so we have 0.325 moles divided by 6 molar, and that gives us 0.0542 liters, or we could say 54.2 milliliters. Okay, now number 7. We are continuing with molarity. So it says calculate the grams of solute needed to prepare each of the following solutions. Okay, so basically we're going to take the volume and the concentration, find the moles, and then use molar mass to go to grams. So again, we're taking the molarity divided by the volume to find moles, and then we can go moles to grams using molar mass. So we have 0.2 molarity and 1 liter, and then we can take that and find the grams using the molar mass of sodium chloride, which is 58.45 grams. And honestly, if we, oops, that's not a good eraser. If instead of writing a big M, you write moles per liter, you can kind of see everything cancel out. So liters is going to cancel here, and then 1 mole, moles cancel out, and so I'm left with grams. Okay, that gives us 11.69 grams of our sodium chloride. Okay, that was for A. And we'll do B. Okay, on B, same thing. We're going to do moles equal to molarity over liters. So we'll do all of that for number 7. So we have 0.125 molar or copper 2 sulfate divided by liters. So we each have to divide the 250 by 1,000. So it becomes 0.25 liters. Oh, I did it again. I meant to put moles per liter. moles per liter. Okay, so liters are canceling. And then I multiply by the molar mass of copper 2 sulfate, which is 159.62 grams per mole. So moles cancel, and that gives me 5 grams copper 2 sulfate. Okay, and then C, we have 0.4 molar. There we go. Divided by, so it's 500 mils, so divide that by 1,000, we get 0.5 liters. Liters are canceling. Multiply by the molar mass of methanol, which is I can't find it. 32, that's what it is. 32 grams per 1 mole. Moles cancel, and I get 6.41 grams of methanol. Okay, that was number 7. Now number 8. Okay, number 8A. Okay, on this one, we're calculating the molarity of the ions. So just because it's an ion doesn't mean anything. We can still do the exact same thing. So they're giving us grams and volume. And so we just, to find the molarity, we need moles and liters. So we just need to change our 0.33 grams of sodium to moles. So we can do that using molar mass of sodium, which is just 23 grams per 1 mole. Okay. And that gives us 0.0143 moles of sodium. And then I need to divide that by the volume, which is 100 milliliters, but we divide by 1,000 to get it into liters, so 0.1 liters. And that will give us a concentration of 0.14 molar. Okay, that was A, now B. Okay, same thing, except now we're starting with 0.38 grams of chlorine. So we need molar mass to get us to moles. Grams will cancel. So that gives us 0.0107 moles. And the volume is 100 mils again, so it's going to be 0.1 liters. And we get 0.11 molar for our concentration. Okay, last one, C. We have 0.4 grams of calcium. Okay, molar mass is 40.08 grams per 1 mole. Okay, oops, not times. So that is going to be 0.00998 moles. Divide by the volume. So we have 50 mils this time. Wait, that's not C, that's D. Okay, apparently I skipped C. We'll go back. So this is D. Okay, so we have 50 mils this time. So we're going to divide that by 1,000 and get 50, or 0.05 liters, which gives us 0.2 molar concentration. Okay, now we'll go back to C. Okay, we have 0.46 grams of sulfate. We need the molar mass of sulfate, and it's 96.07 grams per 1 mole. Okay, that gives us 0.0048 moles. And we have 50 milliliters again, so divide that by 1,000, we get 0.05 liters. And that gives us 0.096 molar for the concentration. Okay, number 9. Okay, this number 9 is all about dilutions. Okay, so number 9, we have 1 mil of a 0.452 molar sodium solution, and we want to know if we dilute it to 25 mils, what's the new concentration? So in the A, we have 1 mil and 0.452, that's M1 and V1. So remember, we're going to use M1, V1 equals M2, V2 to solve dilution problems. Okay, so M1 is 0.452 molar, and then V1 is 1 mil. That's equal to X, because that's what we're going to be solving for, and then 25 mils. So you don't need to change the volume to liters because both of the volumes are in milliliters, so they'll cancel, so you don't have to worry about it. Okay, so we find that X is equal to 0.0181 molar. Okay, so just multiply these two, divide by 25, it gives me 0.0181. Okay, B, we have the same thing happening. They give us M1 and V1, so 3.4, but this one is millimolar, okay? And then, and this is lithium chloride, and they say we have 2 mils. We're going to figure out what's the new concentration if we dilute it to 25 mils. Okay, so again, we just solve for X, and we get 0.272 millimolar, or if you wanted to change it to molar, okay, you would just have to use your prefixes, multiply by 10 to the third, and we would get 2.72 10 to the fourth molar. Okay, C. Okay, we have 6.42 10 to the negative 2 millimolar for our M1. We have 5 mils for V1, and we're solving for X. Oops, I didn't mean to put a plus. Oh, I did that here too. It's supposed to be a times. Sorry. 25. Okay, so X is equal to 0.0128 millimolar, or you can change it to molar and it would be 1.28 10 to the negative fifth molar. Okay, number 10. This one is still a dilution question. So we have 0.05 molar HCl, and it says it can be made by diluting 250 mils of a 10 molar hydrochloric acid solution. So it's wanting to know what is the volume that we can make. Okay, so again, M1V1 equal to M2V2. So our M1 is 10 molar, our V1 is 250 mils. Okay, we have M2, it's 0.05, but we are looking for V2. Okay, so we solve for V2, and we get 50,000 mils, but if I change that to liters, it would just be 50 liters. Okay, number 11, still a dilution solution, or dilution problem. So it says if I add water to 100 mils of a 0.15 molar sodium hydroxide solution until the final volume is 150, what will the molarity of the diluted solution be? So we know the concentration of our M1, and it says we have 100 mils of that. And we know we're looking for M2, and we want to dilute it to 150 mils. So we solve for M2, and we get a 0.1 molar concentration. Okay, number 12. Okay, number 12 is our titration question, and we always need a balanced equation when we're doing a titration. So it says we have 54 mils of a 0.1 molar sodium hydroxide to neutralize 125 mils of hydrochloric acid solution. So we have NaOH and we have HCl. So this is an acid-base reaction. So we're going to get water and a salt. Okay. So that's balanced. So we just have a 1-to-1 mole ratio. Okay, and so what do we have? They say we have a 0.1 molar sodium hydroxide, and we have 54 mils of that. Over here, we have 125 mils of hydrochloric acid, and we're looking for what the concentration is. Okay, so we know for concentration, we need moles per liter. Okay, we have volume, so we've got that. Now we just need moles. Well, we can get to that because we have the concentration of NaOH and the volume of NaOH. And we have a balanced equation. So if I take 0.1 moles per liter and I multiply the liters, 0.054 liters, liters cancels, that gives me moles of NaOH. But I've got to go from moles of NaOH to moles of HCl. It's a 1-to-1 ratio. So the moles will be the same. Okay, that gives me 0.0054 moles of HCl. So I have my missing piece. Okay, I have moles, I have volume now. So I just divide by the liters. And that gives me 0.04 molar for my concentration of HCl. Okay, number 13. So it's another titration question. We need a balanced equation. So we have calcium hydroxide and we have hydrochloric acid. And we're going to get water and a salt. Okay, but we've got to balance this one. Sorry. There we go. So we have 2 chlorine over here. I need 2 chlorine over here. Now I have 4 hydrogen. I need 4 hydrogen over here. And now we're balanced. Okay. So we have 0.25 molar calcium hydroxide and 90 mils of it. Okay, and then over here it says we have 100 mils of HCl, and we want to know what the concentration is of HCl. Okay, so we're going to solve this the same way, right? Moles per liter. We have liters, we just need moles. So we're going to use what we have over here of our base. So we're going to take 0.25 moles per liter, times it by the liters, and then do our mole-to-mole ratio. So we have 1 mole calcium hydroxide to 2 moles, whoops, 2 moles HCl. Okay, so those cancel. That gives me, oh, on the wrong side. It gives me 0.045 moles. Then I can divide that by my liters. So I divide that by 1,000, gives me 0.1 liters. And I have a concentration of 0.45 molar for my HCl. Okay, and 2 more. Number 14. Okay, they give us a balanced equation there. It's everything is just a 1-to-1 ratio. Okay, and this question is asking for the grams of acetic acid, and it gives us the information for sodium hydroxide. So we have 42.4 mils, and we have 1.115 molar. Okay, but we're just going to grams of acetic acid, so we can use this to go to moles, do a mole-to-mole ratio to acetic acid, and then we can go moles to grams to, or using molar mass. Okay, so start with our 1.115 moles per liter. times by our liters. Okay, and our multimole ratio is just a 1-to-1. Should write CH3. And so really that was acetic acid. Oh no, that's not acetic acid. I even wrote it wrong. Oops. Let's try that again. NaOH is down here. Okay. Okay. So that will get me to moles. And then all I need is the molar mass of acetic acid, which is 60.02 grams, to get us to grams of acetic acid, which is going to be 0.293 grams. Okay, last one, 15. Okay, they don't give us a balanced equation here. So we have hydrochloric acid and barium hydroxide going to water and a salt. Okay. I'm out of room, but I should write EQ. Okay, so to balance this, I need a 2 over here and a 2 over here. So 2 chlorine, 4 hydrogen, 1 barium, 2 oxygen, 2 oxygen. So everything's balanced. Okay, they tell us we have 0.12 molar of HCl, and we have a 0.101 molar barium hydroxide, and we have 50 mils of it. And we want to know what is the volume needed for hydrochloric acid. Okay, so we're going to start with this and go to moles, because you always have to use that multimole ratio. And once I find moles of my acid, okay, moles of my acid, then I can take my moles times, or I'm sorry, divided by my concentration to get my volume. Okay, so we're starting with what we know about barium hydroxide. Okay, we're trying to get to that multimole ratio. Okay, so liters are going to cancel. And then we can do our multimole ratio. So 1 mole of barium hydroxide, 2 moles of HCl. So now I have moles. Okay, that's going to be 0.0101 moles of HCl. Okay, so now I can take my moles, 0.0101 moles of HCl, and divide by my concentration, moles per liter. So moles will cancel and I'll be left with liters. So that gives me 0.0842 liters, or I can multiply that by 1,000 and say 84.2 mils.